Imagine waking up, two streets turn into rivers, forcing families to evacuate overnight. This is Jakarta. Jakarta faces some of the worst urban flooding in the world. In March of 2025 alone, over 100,000 people were displaced and damages reached nearly 300 million. The problem is worsened by the fact that nearly 90% of the city's surface is paved, stopping rainwater from soaking into the ground. Clogged drains often blocked by trash causes over half of the flood incidents. These numbers highlight a clear need for practical, affordable solutions that can work in Jakarta's crowded neighborhoods. Jakarta faces severe flooding due to a combination of climate change, urbanization, waste management, and the loss of green spaces. Climate change brings heavier and less predictable rainfall, while rising sea levels pose a serious threat to coastal cities like Jakarta. Urbanization has resulted in 85 to 90% of the surface being covered by roads and concrete, reducing water infiltration. Water mismanagement worsens the issue as trash blocks drains and rivers, increasing flood height and duration. Finally, deforestation and reduced vegetation limit water absorption. Currently, there is a gap. No effective solution has been implemented to relieve flooding in Jakarta's most congested urban areas. The goal of this paper is to propose a practical and green solution to address this issue.
Methodology. This research was largely qualitative, as our models and designs were based on conclusions from other research papers. Our research consists of 3 steps, which are: first, planning. Floods in Jakarta were researched, as well as already existing examples of pervious concrete, trash capturing nets, and bioretention. Second, our conceptual design. The design of a neighborhood with our proposed flood management system was roughly drawn up. Third, detailed design. We used SketchUp to draw designs of pervious sidewalks, trash capturing nets, and bioretaining road media. In addition, bill of quantity charts were drawn up to calculate the costs of 2 different mixed designs of pervious concrete.
Our proposed solution includes a bioretention system designed as a road median. This system manages stormwater, collects street runoff, and helps reduce flooding. It also improves water quality and recharges groundwater. Planted with native vegetation, bioretention median filters oils, heavy metals, and sediments while enhancing the aesthetic value of streetscapes. This is especially beneficial in dense urban areas while space is limited, offering both environmental and visual benefits. The green infrastructure mimics natural processes using water, sun, mulch, and vegetation to create an effective and sustainable approach to stormwater management in Jakarta.
Permeable or pervious surface. This can reduce flooding and runoff by letting more water through, which also helps replenishes the underground water supply. We have 2 formulas for pervious or permeable concrete, which are BP1 and BP2. BP1 has a greater proportion of superplasticizer and water than BP2. Therefore, BP2 is more pervious or permeable than BP1. Besides, the less number of ingredients in BP2 in comparison to BP1 per cubic meter also reduces the cost by 30,299 rupiah. However, BP2 should only be used in sidewalks, as greater porosity sacrifices strength.
The trash catcher is designed for installation under permeable urban road surfaces, directly above small canals where runoff often carries waste. It uses a trapezoidal mesh net fastened with metal hooks and supported by an adjustable rod so it fits different canal widths. The wider base naturally guides trash down, while a weighted block keeps the net in place against water pressure. The mesh allows water to pass through but also traps solid waste, keeping the channels clear. Maintenance is simple. Personnel, press a quick release lever, detach the net, lift it out, empty the contents, rinse if needed, and reattach it securely. This modular, portable system adapts to varying drainage layouts and enable efficient upkeep. For safety and durability, the net should not be allowed to overfill, as this makes it heavier to handle and can strain components. The trash catcher is designed for urban neighborhoods, especially flood-prone areas where drains clog easily. Installed under permeable roads or canal outlets, it intercepts plastics, wrappers, and leaves before they block waterways. Because it's modular, it can be used in multiple sites without major construction, and maintenance can be done by local groups or city agencies. However, there are limitations. The nylon and steel parts still need long-term durability testing, and the system depends on frequent cleaning to stay effective. Its capacity is limited for large storms or heavy waste loads, and no structural analysis has yet been done on how it withstands strong water pressure or debris impacts. Looking ahead, improvements could include stronger or sustainable materials, adding sensors to alert when the net is full, scaling up designs for larger canals, and recovering resources from collected waste. Pilot projects in Jakarta could measure real-world performance, costs, and flood reduction benefits.
In conclusion, Jakarta's flood come from too much concrete and clogged drains. Our solution combines permeable pavements, bioretention, and trash capturing device. Together, they reduce runoff, keep streams clear, and offer a low-cost, community-driven way to build resilience. Our recommendations are simple. First, test the strength and performance of pavements, bioretention, and the trash device. Second, run simulations to see how they work under heavy rain and debris. Third, try pilot projects in flood-prone areas and monitor results. Fourth, involve the community in maintenance with small incentives. Finally, study long-term costs to ensure that the system is affordable.